Hello students of CCS Academy 12th class. This is your solution chapter number 1 of your 12th class chemistry syllabus. This is the heading number 3rd. This is your third video. In the first two video I've explained you what is solution, what is the various aspects of solution, and also what is vapor pressure and what is the factor affecting the vapor pressure. So in this heading I'm going to come to the very important heading according to CBSE and according to this syllabus and this chapter, that is Raoult's law. Okay, for a non-volatile solute. Before discussing Raoult's law in detail with the help of figure, I am going to tell you what is non-volatile solution. Okay, students, I have told you earlier that solutions are something which consists of two parts, maybe more than two parts, but I told you we will discuss only binary solution. What is binary solution? You can connect with the previous videos that binary solution is that which consists of two components. A is solvent and B is solute. What is non-volatile solute? Non-volatile solute is that student which never generates vapor. Suppose I am going to explain you with the help of example. Suppose you have water and you are going to make solution with the help of salt. What will happen? When salt will dissolve, there would be no practical vapor of that salt. So it is non-volatile. Suppose again you are taking water and you are going to add ethyl alcohol in that, then ethyl alcohol is liquid, it will generate vapor, so it will volatile solute. So in this heading number 3, students, as you can see, I am going closer. Raoult's law for a non-volatile solute. Okay, the statement of this law is the vapor pressure. I told you what is vapor pressure. You know this. You can connect with the previous videos of the solution. You know what is solution? Containing a non-volatile solute. You can ask student, what is non-volatile solute? I am telling you, non-volatile solute is something which never generates vapor on that physical condition. On that physical condition means I am saying at that temperature and pressure, is directly proportional to the mole fraction of the solvent. Okay, this is the statement of the Raoult's law. Okay students, now I'm going to explain the same thing with the help of my figure number 3a. As you can see here, 3a and 3b. Okay student, in 3a what you are seeing there, 3 liter of H2. As you know, 3 liter of H2 is a volatile solvent. It will generate vapor. As you can see here, there are vapors of this liquid generated by the surface of this liquid. Okay students, so PA naught, what is P? P is the pressure. A is, as you know, A is always used for solvent. I told you earlier, naught means maximum. What is the meaning of maximum? First I read this, vapor pressure of solvent. Okay, suppose at the same time, the same time there's figure number 3b. What is here? Is here the 3 liter of H2O and 1 mole C6H12O6. So you can ask, there's no vapor? No. I'm not saying that. There would be vapor, but that vapor would be lesser this time. Why lesser? I'm going to tell you. What I added here? I added here the non-volatile solute, that was glucose. Okay, glucose is solid at that temperature, so will not generate any kind of pressure. So you can see, you can symbolize, I'm symbolizing here, there are lesser vapor. So this is solution. So I'm not writing just like the case of 3a, vapor pressure of solvent. What I am writing here? I am writing here vapor pressure of solution. Means I want to say in these two figures, students, I am going to explain you one more time. This purely volatile solvent. In this pure volatile solvent, there are only vapors. So vapor pressure of solvent. What is the symbol of that? PA naught. As you know, P is the vapor pressure of solvent and not for the maximum. Why maximum? You can understand that surface contains only volatile liquid H2O. So all surface area will generate the vapor. Again at the same time, when I am going to add the non-volatile glucose, the surface will contain some non-volatile solute also. It will not generate the vapor. As you can see, the lesser vapor here. So you can say, students, this is the vapor pressure of solution, which definitely is going to be the lesser than the vapor pressure of pure salt. Okay students, so I am going to read after explaining this two figure, this statement more. It seems to you that why are you emphasizing this Raoult's law? I am telling you because Raoult's law is the basic bone of the forthcoming heading in this chapter. Now again I am going to read. The vapor pressure of the solution containing a non-volatile solute. I told you what is non-volatile solute is directly proportional to the mole fraction of the solvent. You can ask, sir, why it is directly proportional to the mole fraction of solvent? I told you in this case, in these two cases, who generates the vapor? Definitely students, solvent is generating the vapors, not solutes. So if solute is not generating the vapors, how the vapor pressure of the solution depends on the mole fraction of solute? So definitely there would be solvent. Okay students, on the basis of this figure 3a and 3b, you can easily understand this seemingly simple Raoult's law. Okay, what is Raoult's law? The vapor pressure of the solution containing a non-volatile solute is directly proportional to the mole fraction of the solvent. Why not solute? I told you. Because solute is non-volatile. Look here, non-volatile solute. So it will not generate any pressure. So this would be solvent. Means more the solvent, more surface area will be generate vapor and more is the vapor pressure. So I hope students you got this statement. Okay, further, since this is the qualitative statement and I told you so many times in 11th class and in 12th class, then physical chemistry requires mathematics as well as. Okay, so I'm going to shift to the page numbers 8. I will connect again with the page number 7, but I'm going to convert this law mathematically, quantitatively, students. So come to the page number 8. What is in page number 8? You can see in figure 3a and b, mathematically I shown you earlier. Vapor pressure of the solution is P. What is the symbol of vapor pressure of solution, students? Look here, P. Okay, that is PA. Why there is no PB? Because I told you in this case B is non-volatile. So how it can generate the vapor? So definitely, students, this vapor pressure of the solution P is equal to PA, not PA plus PB. Why PB is not here? Because PB is non-volatile. So PA is directly proportional to xi A. I told you in the statement, mole fraction of the solvent. Look here. Okay, I am coming back to my mathematical form. P is equal to PA. Okay, students, P equal to PA. Directly proportional to xi A. This implies P equal to PA is equal to K into xi A. What is K? You know that when this proportionality sign will remove, this K comes. I am explaining you. I told you so many times in chemistry, this K is the proportionality constant. Again, if xi A is 1, what is xi A? I told you here, look at that. Xi A, according to the knowledge of 11th class, Na upon Na plus Nb. And xi A would be 1 when Nb would be 0. Look here, look at. I'm going to closer to explain you. How xi A would be 1? I told you there is xi A 1. Xi A would be 1 when Nb is equal to 0. Nb means, what is B? Non-volatile. I told you in the figure. Look here. Yes, I told you. It is non-volatile. So when non-volatile solute will not present, then Na upon Na is 1. Means in figure 3a, there is only solvent. Okay, this would be maximum. So look, on the basis of this figure, you can say if xi A equal to 1, then P is equal to PA and P equal to not maximum. Why maximum? Because only solvent is present. The vapor pressure of the solvent or pure liquid. Okay, then from equation 1, if I am putting xi A 1, then P would be PA. I told you if xi A equal to 1, then P equal to PA. Then put here, PA would be PA naught, student. Okay, look here, PA naught. And K and xi A is 1. Look at K is multiplied by 1. Again, K is equal to PA. In this equation number 1, we have K, and in equation number 2, we have the value of K on the basis of this condition, that is PA naught. Okay, students, so this value of 2 would be put it here. Look, I am going to turn the page. Look at that. Now you are on the page number 9. From equation 1 and 2, we have P is equal to PA equal to K was there. Look here, I am going to turn it back again. What was in equation number 1? P equal to PA, K psi A. PA would be PA naught, K would be, P is equal to PA, K is IA, K value has come into 2 I will put in 1. Now we get the final equation. P is equal to, look here students, P equal to PA is equal to PA naught psi A. This is your equation number 3. What is equation number 3? Why I am quoting here? I am quoting here because this is the mathematical form of RAOULTS law for a non-volatile solute. So what you have? You have two very interesting things. I am turning page again of this video. Now come to your heading number 3. In this whole statement, on the basis of this figure, I explained you this law. And what is the mathematical form of that? Now come to the page number, directly on page number 9. This is the mathematical form of RAOULTS law for a non-volatile solute. Okay students, so I finished the video number 3 of your chapter 1 solution and the heading number 3, which was RAOULTS law. Okay.